Guys, I'm here to help you with problem number 23.9 from homework 4, or the generic problem of a 10 centimeter thin glass rod uniformly charged to 12 nanocoulombs and a 10 centimeter thin plastic rod uniformly charged to negative 12 nanocoulombs are placed side by side 3.6 centimeters apart. What are the electric field strengths E1 to E3 at distances 1 centimeter, 2 centimeter, and 3 centimeters from the glass rod along the line connecting in the midpoints of the two rods? Man, what a crazy question. But solvable. So first, I thought it would be helpful that I draw a diagram explaining the question. So here we have our glass rod that's positively charged to 12 nanocoulombs. And here we have our plastic rod that's charged to negative 12 nanocoulombs. And they're both 3.6 centimeters away, with all our points in the middle, in a line by connecting the two rods in the middle of them that are 1 centimeter, 2 centimeter, and 3 centimeter away. Now, being that this is a positively charged object, the E field is going to be pushing away from the source. Being that this is a negatively charged object, the E field is going to be pulling into the source. So anyways, the question is, what is the electric field strength for E1 to 3? So, to calculate this, I kind of just thought this equation would help us a lot better, being that we're looking for the total net electrical field strength equaling the which is the electrical field strength from the plastic rod plus the electrical field strength from the glass rod. Now, looking back at our diagram, being that the forces in this area are within the 3 centimeters between or 3.6 centimeters in between the two rods, goes downwards, I drew this full body diagram saying that it's only going to go down, which is exactly why we're using a positive and or a plus sign, not a minus sign. Anyways, the next step would simply just to be to solve for for the electric field strength for the glass rod and the electric field strength for the plastic rod, which I'm just going to call E of G and E of P for each point. Now each point is for part A, part B, part C. So I'm just going to give you guys the generic formula, which I found in our book, which is just simply Coulomb's constant, which is 8.99 times 10 to the 9th, times the charge of the object, which is usually in nanocoulombs. So the exponents cancel, divided by the distance of the particle times the square root of the distance of our particle squared plus the length of the rod divided by 2, or length of the rod divided by 2 squared. Now I found this on example 23.3 for the 4th edition, and I'm assuming it's an example 26.3 in the 3rd edition. I only have the 4th, so I can't really help you if you have the 3rd. That's just my guess. So, going back here, essentially in the previous picture, I already explained it, but here's just what I said. And I kind of also have a generic thing to tell, or a note to think about is that the position for the E of P is not going to be the same number as for the glass rod, because it's either further away or closer. So to fix that problem, we would subtract the distance from the glass rod by the distance in between as a total. Anyways, wrapping this up real quick, Essentially, we take our equation from over yonder, from our first part, which is essentially that the electric field strength net equals the electric field strength of the glass rod plus the electric field strength of the plastic rod. In which case we get Coulomb's constant times the source of the charge times the distance of the particle from the glass rod times the distance of the particle from glass rod squared plus the length of the rod divided by 2 squared plus essentially the same thing, except the distances would be from the plastic rod. And essentially for each of the questions, D is going to be the only thing that changes. So a note would be to save K, if you have a calculator or you're doing it on your phone. Save whatever this comes out to be, and save whatever that comes out to be, which that would just be 0.05 meters, 5 centimeters. And this would be like 107.88, I believe, because remember, the 10 times the 10 to the 9th would cancel with the 10 to the negative 9th. Anyways, that's essentially this problem, or the process of this problem. I'm not really going to give you the answers, because I know you guys can whip out your calculators and solve it for yourselves. Plus, that'd just be too boring of me. So, yeah. Good luck, guys. I know you can do it.